got this extra question I thought I'd go over. Again, it's to do with walls and distance speed type. So it's a sort of question I think students struggle with, but I thought I'd go over this example here just to help even further with this sort of topic, okay? So the first part's actually straightforward. So again, we've got a standard collision scenario. So we've got A and B here. And for A, again, the mass is 2m. And for B, the mass is 3m. Okay. As for speeds, well, we're told that they're both moving in the same direction. So A and B in this case are going to move forwards. And A has speed 2u and B has speed u. Okay, so hopefully happy with this. Now, as for the directions afterwards, well, we're not really told where either of them are going. So the best assumption to make really is that, let's say they both go forwards, right? I've noticed with the textbook, it always assumes they both move forwards unless told otherwise. And that's not bad advice really, because they're both in the positive direction, so it makes things a tad bit easier to work with. But again, it doesn't really matter. If you get it wrong, it should be negative anyway, but there we are. Now, we're going to then apply the usual stuff. So momentum firstly. So again, that's going to be 2m lots of 2u for A. And then 3m lots of u for B is going to equal 2m lots of V1 and 3m lots of V2. So if we simplify this, we get 4mu add 3mu is 2mv1 add 3mv2. Then we can cancel the m's. And so we get 4u add 3u to be 2v1 add 3v2. Therefore, we get the equation 2v1 add 3v2 is 7u. And that's my first equation. Then if we look at restitution, so that's going to be E, and my standard formula is v2 take away v1 over u1 take away u2. Well, literally it's just v2 minus v1. Okay, v2 minus v1 there. And then u1 take away u2 is going to be 2u take away u, right? And that simplifies to v2 take away v1 over u. And so if this is equal to E, we can say E lots of u is v2 take away v1. And that's my second equation there. So I've got the simultaneous equations, minus v1 and v2 is EU, but also 2v1 and 3v2 is 7u. Right? And so at that point, this is my equation 1 and 2. So let's double the first equation. So I get minus 2v1 add 2v2 to be 2EU. Then I'm going to rewrite the second equation, and then I can add these equations to get rid of the v1. So I have 5v2 to be 2eu add 7u. So then I can divide by 5 to get v2 to be a fifth of 2eu add 7u. Then I can factor u out to say v2 is a fifth u of 2e plus 7, and that's my expression for v2. Then if I go on to find v1, so I'm going to sub v2 into either equation. Let's substitute it into the first one. So minus v1 add v2 is 2eu. Oh no, sorry, eu, sorry. So I'm going to sub v2 into this equation. So therefore minus v1 add a fifth u of 2e plus 7 is EU. Therefore v1, hopefully you can see it's going to be a fifth u of 2e plus 7 take away EU. And so if we now expand it to help simplify our answer, it's going to be 2/5 EU at 7/5 U minus EU. And then notice I have 2/5 EU minus EU here. If I collect the EUs, I have a minus 3/7 EU plus a 7/5 U. And then we can factor out 1/5 U, and that'll get me 7 take away 3E. And that is my expression for V1 there. Hopefully happy with all of this, and then you're happy with the factorisation and the algebra here. So that's my two speeds. Now, just to confirm, my speed for B should be a 5th U of 7 plus 2E. That's indeed what we got. Okay, so we should be on the right lines. Okay, I found the speed for A. Then it says the speed of A is actually 11/10U. We need to show that E is a half. So actually it tells me that V1, so V1 for A should actually be 11/10U. So actually what we can do is we can equate my expression for V1 to be 11/10U. Therefore, a 5th U of 7 minus 3E is equal to 11/10U. Hopefully then you can spot I can firstly get rid of the U. So we get a 5th of 7 minus 3E is 11/10. Then I can get rid of the fraction of 5th. I can multiply everything by 5. So just 7 minus 3E is going to be 55/10. Then, hopefully you can spot 3E is going to be 7 take away 55/10. So that simplifies to 3/2. Okay, and therefore divide by 3, we get E on its own to be a half. Okay, and there we are. So we've shown that E has to be a half there. Okay, so that should be fairly sort of standardish. Hopefully nothing's thrown you off at this point, but there we are. Hopefully happy up to here. Okay, now we're going to look at the walls business. So we're told at the instant of collision, A and B are at a distance D from a vertical barrier, which is basically going to be my wall, right? It's a vertical barrier. Vertical means it's sort of like a wall, right? Given that B hits the barrier and the coefficient of restitution between B and the barrier is 1/16, we need to find some distances. Okay, but let's not worry about that at the moment. Let's actually draw the situation. Again, you must draw a diagram to help you out here. So my strategy with these questions, if you went through questions like this before, is I want to consider the different particles A and B. I want to do their journeys separately. So firstly, I'm just going to consider B. So again, I've got a floor, right? And then I've got my wall, which is essentially my barrier, right? Now, what we're considering is we are considering from after A and B collide to then when B hits the barrier. Okay, so after A and B collide, let's say they're over here, right? Let's say we have A and B here. This is after the first collision, okay, which we just looked at. And so then B is going to move forwards and then it's going to hit the wall, okay. Now, I'm going to label this now my point 1 and point 2. These are my first 2 points in B's journey. So B starts after the collision, then moves to the wall. Hopefully happy with this, okay. Now, what about my speeds? Well, B has speed V2, right? Well, we know that V2 is a 5th U of 2E plus 7. And actually, we know that E is a half. So let me simplify this. So V2 was a 5th U of 2E plus 7, I believe. Yes. So if we substitute if we substitute e as a half into this, it's a fifth u of 2 lots of a half plus 7. And actually that will simplify to an 8 over 5u. So that is v2. So that's going to be the speed 8 over 5u. That's the speed of b after the collision. And so that's the speed it's going to approach the wall with. Okay, hopefully happy with that. Okay. Then I'm going to consider a. So for a, what it wants me to work out firstly is the distance. It wants me to find the distance of A from the wall at the instant that B hits the wall. So we want to find basically where is A when B hits the wall. So what I'm going to do there is, so the point 2 is where B hits the wall. So if I draw the motion for A, then again a very similar diagram. A is going to start at the same point, right, after the collision, right? So that's going to be point 1, right? But then, when B hits the wall, well, A is going to be slower. So let's say A is over here. So this is going to be my point 2, right? So when B is at the wall at point 2, let's say A is somewhere here at the same point 2. Okay, so hopefully you're happy with that. And so A moves forward. What is the speed of A? Well, it's v1. But we discussed that v1 is 11 over 10u. Okay, so 11 over 10u is the speed of A here. And hopefully happy with that. Hopefully happy with the diagram for A here, right? So again, A and B start at the same point after the first collision. So again, this is my first collision. And then when B hits the wall at point 2, A is somewhere here at point 2 at that point in time. Hopefully happy with that then, right? Now it wants me to find the distance here. Okay, what is this distance going to be? It wants me to find the distance from the wall. Sorry, so it wants me to find this distance here. Okay, remember what the question said. The question said, find the distance of A from the wall at that point. Okay, so sorry, it should be that. It should be that distance. It should be this distance here from point 2 to the wall. Okay. What else? Okay. So what we're told in the question then, we are told that A and B after the collision is a distance D from the wall. So from the collision to the wall, that distance is D. So if I label this on my diagram then, well, the distance from the collision to the wall is this distance D here, right, from point 1 to point 2. Hopefully happy with that then, right? The distance from the collision to the wall is D here. And actually then I could label again the same distance here from point 1 to the wall is D as well. And so there we are. Now, that's all the information I'm given. So, if I look at point B, what do I know? I know a speed and I know the distance from the points. I can then work out the time, can't I? So, for B, the time from point 1 to point 2, well, again, that's going to be distance. That's going to be distance over speed. That's my formula for time, right? Okay, well, the distance for B between these 2 points is D, right? And the speed is 8 over 5u. So it's going to be D divided by 8u over 5. Again, if you're struggling to simplify this fraction, split it up, right? So it's going to be D divided by 8u over 5. If you then do keep flip change, that's going to be D times 5 over 8u. So it's going to be 5D over 8u. And there we are. Well, actually, because that tells me the time from point 1 to point 2. Well, it's going to be the same time from point 1 to point 2 for A, because it's the same points from 1 to 2, right? So it's the same points in time. So if I now consider A, so I know the time from point 1 to point 2, and I know the speed from point 1 to point 2, so I can work out the distance here. I'm going to call that distance x, right? That's the distance from point 1 to point 2, right? So I'm going to now calculate the distance from 1 to 2. And this is for A, right? So that's going to again be, well, speed times time, right? That's my formula for distance, speed times time. Well, for A, the speed is again 11 over 10u, and the time is this expression here. So it's going to be 11 over 10u times 5d over 8u. And so if we work this out, that's going to be 55 d over 80. The u's will cancel, right? And so there we are. We can simplify that even further to be 11 over 16d. And there we are. So now I can label x here, my distance from point 1 to point 2 of 11 over 16d. Hopefully happy with that. Now, the question wanted the distance from A to the wall here. It wants that distance here. But actually, look, I have got the whole distance D and then this distance here. So actually, to work out the distance from point 2 to the wall, it's going to be D take away 11 over 16D. So therefore, distance from 2 to the wall is going to be D take away 11 over 16d, and that's going to get me 5 over 16 lots of d. And there we are. That is the distance here. And hopefully happy with that then. Hopefully happy with that. Again, this is why I always draw a diagram like this, because it really helps to visualise all the distances and times at play here. Okay. Hopefully you're happy with this, right? That is the distance from point 2 to the wall. Okay. And so there we are. Right. Now, what we're then told is to show that after B rebounds from the wall, it collides with A again at a distance 5 over 32D from the barrier. Okay, so now we want to consider when B rebounds off the wall and then they collide again. Okay, so remember E is 1 over 16 for the wall. I'm going to label that. So E is 1 over 16. Now, we now want to consider when B then bounces off the wall. So B at point 2 is going to leave the wall. Well, if E is 1 over 16, the rebound speed is going to be the initial speed 8 over 5u times 11 over 16. So the speed after it bounces off the wall is going to be 11 over 10u. Okay. And so there we are. And then they're going to collide again. So A and B are then going to collide again. So let's say they collide, let's say over here, right? And I'm going to call this then point 3. So this is point 3 in the journey. And so there we are. Okay. So hopefully happy with that. So B then leaves the wall at point 2 with speed 11 over 10u, and then it goes to A again. Okay. So hopefully happy with that. Then I'm going to do the same for A. So then A is going to continue moving forward, and then it's going to hit B at the same point, right? Then it's going to hit B here. And this is going to be point 3. Okay, this is going to be point 3. Let me... point 3 there. And so hopefully happy with that. Okay, and this is going to be my second collision if you were to add that on. So hopefully happy with the diagram now. So now I'm considering after B leaves the wall at point 2 and then they collide again at point 3. Okay, and so in that same time from point 2 to point 3, A is going to continue moving forward and then hits B again here. Okay, hopefully happy with the time frame here. So there we are. Now the distance the question wants me to work out is again the distance from the second collision to the wall. Now if we look at a diagram, the distance from the second collision to the wall, well, it's going to be this distance here from point 3 to point 2. Okay, and I'm going to call that Y. Okay, so hopefully happy with that. So the distance from the collision to the wall is from point 3 to point 2 here. Hopefully you're happy with that. Okay, well actually that's going to match this distance here. Okay, this is also going to be Y from point 3 to the wall. It's the exact same distance. Now, if I look at my diagram, I can also work out an expression for the distance from point 2 to point 3 here. Well, if the overall distance is 5/16d, and then this distance is Y, well, this distance from point 2 to point 3 is going to be 5/16d take away Y, right? And there we are. So we have an expression for the distance from point 2 to point 3. And we have the speeds from point 2 to point 3. Okay. So I can work out an expression for the time from point 2 to point 3 for A, right? So time from point 2 to point 3. So that's going to be the distance divided by speed. And again, as I remind you, the distance we just worked out, the distance from point 2 to point 3 is 5/16d take away Y. Okay. And then the speed, well, the speed from point 2 to point 3 is again 11/10u for A, right? And so we can simplify this. Again, if you're struggling, we could say that's 5/16d take away Y times, divided by 11u/10. And so this is then going to be 5/16d take away Y times, and then we flip the fraction to 10 over 11u. And so that's going to be 10 lots of 5/16d take away Y. All over 11u, and then we can expand the bracket on the top. So that's going to be 50/16d take away 10y over 11u. So this is my time from point 2 to point 3. Well, that's going to be the same time from point 2 to point 3 for B, right? It's the same points in time, right? It's from point 2 to point 3. So we have an expression for the time from point 2 to point 3 for B, and we know the speed for B. So we can work out the distance, Y, from point 2 to point 3. So now if I now consider B, the distance from point 2 to point 3, that B travels, well, again, that's going to be speed times time. The speed, again, if I remind you, the speed for B from point 2 to 3 is 11/10u. And the time, well, it's the same time we worked out here. The time from point 2 to point 3 of 50/16d take away 10y over 11u. Okay, it's quite a nasty expression, but let's deal with the algebra. So firstly, if we multiply the numerators, okay, so that's going to be 11u lots of 50/16d take away 10y. All over 10 lots of 11u. Okay, make sure you're happy with the algebra here. Okay, so hopefully happy with this. And then, well, actually, notice I can cancel 11u to top and bottom. So we just left with 50 over 16d take away 10y all over 10. And so we can further split this up to say this is 50 over 16d all over 10 take away 10y over 10. But the 10's cancel, so I'm just left with y. And so if we simplify this fraction here, again you can do keep flip change if you want. You could say 50 over 16d divided by 10, but that's same as multiplying by 1 over 10, so that should be 50d over 160. So this is 50d over 160 take away y. Okay, hopefully happy with that. So we should get to this answer here, but remember we're working out the distance from point 2 to point 3 for d. If we have a look at our diagram, to remind you, the distance from point 2 to point 3 for b is y, right? So this is equal to y, right? So therefore this whole expression equals y. So y equals 50d take away 100 over 160 take away y. So if we add y to both sides, we get 2y is 50d over 160. Actually, this simplifies. 50 over 160 is 5 over 16. Lots of d. Therefore, if we divide by 2, we just get y to be 5 over 32. Lots of d. And there we are. So y is now 5 over 32 lots of d. That is the distance. This is the distance between the second collision and the wall, which is what they wanted to work out. And you can see I got the answer they wanted, right? 5 over 32 lots of d. So there we are. Okay, again, the algebra was quite ugly there, but hopefully that made some sort of sense, right? So again, the strategy of these questions, I like to do a diagram for each particle separately and then motions throughout, okay? And so then you can piece together all the information and you can use distance, speed, time to work out anything else. And you should hopefully get to the answer there, okay? But hopefully that's helped, but I'll see you next time.